Hello everyone, so I welcome you to today's lesson where I will be talking about complex numbers, which is some of the topics under the complex analysis. So without wasting any time, let's get into it. If you are watching for the first time, don't forget to press the subscription button, like, share, and subscribe. So yeah, let's get into the content. So the complex numbers, since you can see now, we want to talk about complex numbers. So let's talk about the definition of complex number. So what complex number is. So now a complex number is any number of the form z equals to a plus ib. So where a and b are real numbers and I itself is the imaginary number. So any number of this form z equals to a plus ib is called a complex number. Remember, a and b, they are real numbers and I is the imaginary unit. Remember, I, it represents square root of negative 1. So I represent the square root of negative 1. So take note that the real number a in this complex number is called a real part. So we call a real part, so of the complex number z, and the real number b in the complex number z is called the imaginary part of z. So it is called the imaginary part. So a is the real part and b is the imaginary part. So these real parts and imaginary parts are complex number of z. They are denoted by the RE of z and IM of z, which stand for real part of z and imaginary part of z. So that's their denotion. So we denote real and imaginary parts of a complex number z as RE of z and IM of z respectively. So for an example, let's take an example. So for example, if we have this complex number z equals to 5 minus 2i, then its real part is equals to 5 and imaginary part equals to minus 2. That's how simple it is. So now take note that the real constant multiple of the imaginary unit, so is called the pure imaginary number. For example, so if we have z equals to negative 6r, this is called a pure imaginary number, because the definition is saying that a real constant multiple of the imaginary unit is called a pure imaginary number. So z equals to minus 6i is a pure imaginary number. So let's look the second definition, the equality of complex numbers. When do we say two complex numbers are precisely equal? So now complex numbers say, let's say two complex numbers say z1 equals to a plus ib and z2 equals to x plus iy. They are said to be equal. In mathematical presentation, we say that z1 equals to z2 if the corresponding real and imaginary parts are equal, they are equivalent. So that is if a is equals to x, because this is the real part of complex number z1 and x is the real part of complex number z2, they should be equal, and also their imaginary part should be equal in order for one to say that two complex numbers, they are equal. So in terms of symbols, RZ and imaginary of z, we can say that z1 is equals to zt. These two complex numbers are equal if the real number, the real part of the complex number z1 is equals to the real part of the complex number z2. Similarly, imaginary part of complex number z1 is equivalent to the imaginary part of complex number z2. So be aware that the set of all complex numbers, so the set of all complex numbers is denoted by a letter shaped like S. So let me say not a letter shaped like S, but a letter shaped like C. Let me just say the set of all complex numbers is denoted by C. So that is its denotion. So the complex number is a subset of real number, but the converse is not true, because real number is not subset of complex number. So that's what you have to bear in mind. So now let's transverse in this order. So let's talk about arithmetic operations of complex numbers. So we have arithmetic operations. So note that complex numbers can be added, subtracted, multiplied, and divided. So if we let Z1 be a first complex number with a real part A plus imaginary part IB, and Z2 equals to X plus IY, then the operations can be defined as follows. So let's talk about addition or subtraction. So Z1 plus or minus Z2, this can be written as A plus IB plus or minus this, which is X plus IY. This is just equal to, this would be this real part plus or minus this real part. This is A plus or minus X, then plus this one plus or minus this one. So this will be I into B plus or minus Y. So we add the real part together and the imaginary part together. So that's how we add or subtract two complex numbers. Multiplication. Two complex numbers can be multiplied together. So Z1 can be multiplied with Z2. So this is just equals to A plus IB times X plus IY. This is just equal to, we can multiply. So we multiply as usual, how we multiply two binomial, that's how we multiply. So this will be AX, this one times this one, AX, then plus IAY, then plus IBX, then plus I squared BY. Remember, I represent square root of -1 in complex number. So I squared will be square root of -1 all squared, which is just -1, meaning that I squared is -1. So this will be equals to, then AX plus I, we can take I outside here, we have AY plus beta BX, sorry. So this will be I squared is -1, this positive will change to negative, so it will be minus BY. So we can group the like terms together, so this will be AX minus BY, so plus I AY plus BX. So this is how we multiply two complex numbers. So let's go to division. So two complex numbers can be divided. So likewise, Z1 divided by Z2, this will be equals to A plus B IB, or BI is the same thing, so IB over X plus IY. So here we multiply by we have to rationalize, or we multiply by complex conjugate of X plus IY, which we will discuss this concept in the next lecture. So this will be X minus IY over X minus IY. So this is the complex conjugate of X plus IY. So this will be equals to, when we multiply them, we have AX, then minus IAY, then plus IBX, then minus, because I and I is I squared, it becomes plus BY, so plus BY, all divided by, this one is like different between two square. It's like multiplying X or a minus b, a plus b, where you just have to say is a squared minus b squared. It's like that. So then we have to do the very same process here, which will be x times x. It's x squared minus, because I and I is I squared, which is -1, to be plus y squared. So this will be just equal to, we group the like term ax plus by minus I outside, because it's a common factor. Then we have ay minus bx inside, all divided by x squared plus y squared. If you like it, you can separate, you can represent it in the, when we've got the real part separate and imaginary part separate, like this. This would be ax plus by, all divided by x squared plus y squared minus I ay minus bx, all divided by x squared plus y squared. That's how simple we divide two complex numbers. Let's go to the properties of complex numbers. Take note that commutative laws, associative laws, and distributive laws are also applicable in complex numbers. So we'll talk about commutative laws in multiplication and also in addition. So if we've got two complex numbers, z1 and z2, then z1 plus z2 is the same as z2 plus z1. Also z1 times z2 is the same as z2 times z1. This is commutative laws. So associative laws, z1 plus z2 plus z3. So if we're first adding z1 plus z2 plus z3, then this will be the same as first adding z2 plus z3, then add z1. So that is an associative law. So then also, if we first multiply z1 times z2, then z3, this will be the same as first multiplying z2, z3, then z1. We multiply these together. We multiply z1, z2, z3 first, and then z1. So that those are associative laws. So we also have got distributive laws. So distributive law, not laws, because it's the only one. So here we have z1 times z2 plus z3. So then we are allowed to distribute z1 to each complex number here inside the brackets. So this will be z1 times z2 plus z1 times z3. So that's how we distribute a complex number. So for example, if we are given z1 equals to 2 plus 4i and z2 equals to minus 3 plus 8i, then let's find z1 plus z2 and also z1 times z2. So a solution here, we need to find z1 plus z2. But what is z1? It's 2 plus 4i, then plus what is z2? It's minus 3 plus 8i. So this is just equal to, then we'll add to the real parts together, which is just 2 plus minus 3, then plus I outside 4 plus 8. So this will just be equal to minus 1 plus 12i. So that's how we add to these two complex numbers. So this is Roman figure number 1. So Roman figure number 2, we have z1 times z2. This will just be equal to 2 plus 4i times minus 3 plus 8i. So this will just be equal to, this times this one is minus 6 plus this one times this one is 16i. This one and this one is minus 12i. That one is plus is 8 16 8, 16, 24, 32 I squared. So 32 I squared. So this will be equal to minus 6. This one and this one, 16 minus 12 is plus 4I. Then I squared is negative 1, which will be minus 32. So this will just be equals to this one. Minus 6 minus 32 is minus 38 plus 4I. So that's how we multiply these two complex numbers. Likewise, how we multiply two binomial, that's how we do it. So now let's go to some exercises. So these are exercises, so you can pause and try it out before you see me doing it. So this will exercise your brain. So now the first question says evaluate the following powers of I. So here we've got I to the power 8, I to the power 11, and I to the power 105. So how do we do this one? Solution. So I to the power 8, let's also change the color here. So I to the power 8 is equals to, so this can be given by I, but the factors of 8 is 2 and 4. So this will just be equals to I. We're allowed to write it like this by exponential laws. But I to the power 2 or I squared is just negative 1. This is just equals to negative 1 to the power 4. Because the exponent is even number, so this will appear as 1. It's a positive 1. So that's how simple we do it. So number B, so it will be I to the power 11, which is just be equals to, this can be given by, can be expanded as I to the power 10 times I to the power 1. I to the power 10 times I to the power 1. This will just be equal to, but the factors of 10 is 5 times 2 times I. This can be given, this I to the power 5 times 2 can be written as I to the power 2 to the power 5 times I. So this will just be equal to, but I to the power 2 is negative 1. This is just equals to negative 1 to the power 5 times I. But because the index or the exponent is odd number, so this will just be equals to negative 1 times I, which is just equal to negative I. So number C, I to the power 105. So this can be given as, can be written as I to the power 104 times I. But 104, the factors is 2 times 52 times I. So this can be written as I to the power 2 or to the power 52 times I. But we know, we are familiar with the issue that I to the power 2 is just minus 1 to the power 52 times I. But 52 is an even number, so this will appear as 1 times I, which is just an I. Thus this is the final answer. This is just an I. So the second problem, so you can pause and try this one. Write the given numbers in the form of A plus IB. So we're given some mixed complex numbers, so we need to represent them in the form of A plus IB. So now here we have to solution. So we know that A is just 5 over I plus 2 over I cube minus 20 over I to the power 18. This is just equal to, then we can multiply by I, which will be I here. So this will be 5I divided by I squared. We multiply by 1, then plus this will be 2I to the power 4. So which can be written as this 1 squared or squared. So this will be minus 2, but this 18 can be written as 2 times 9, which will be I squared into 9. So this will just be equal to, so then this one is negative I squared. This will be negative 5I. This one is also -1. This one is -1, but -1 to the power 2 is positive. This would be 2i. So this one is negative, but because the index is an odd number, this one will be positive. This one will be negative, then will be positive 20. So then this is just equals to minus 20 minus 3i. So then we represent it in the form of a plus ib. So now let's look at the second problem. So number B is 2i to the power 6 plus 2 over negative I to the power 3 plus 5i to the power negative 5 minus 12i. So this is just equals to, so this is 2i because the factors of 6 is 2 and 3. This will be I to the power 2 all to the power 3. Then this will just be plus 2 to the power 3 is 8. Then minus I to the power 3, which can be written as let's say it's I to the power 3. It's fine. So then this one is can be written as plus 5 I to the power 4. Let's say I to the power 5, and we take out -1 outside. So that's how we can do it. Then minus 12i. So this will just be equal to, this one is -1, 2 into -1 to the power 3. This one can be written as minus 8i when you multiply by 1, which is I over I, which will be I2 to the power 2. Because when you multiply this by I to be I to the power 4, factors of 4 is 2 and 2, then it can be written as I to the power 2 all to the power 2. So this will just be plus 5 I to the power 4, which can be written as I to the power 2 all to the power 2 times I to the power -1 here, then minus 12i. So this would be equals to, this one is -2, then this one is minus I, then minus I to the power 2 is positive, then it's just minus 8i, then plus 5, then this one is negative 1, which is just -1 to the power 2, which is not as I to the power -1 minus 12, then I. So this is just equals to -2. Then this one and this one is we can add the 2. This will be plus 5 over I. That's how we can write this one. This one can be written as 5 over I, but this 2 can be written as minus 20i. So this is just equals to -2. Then we can multiply by I over I, which is I square minus 20i. So this is just equals to -2. Then this one is just minus, because this is -1, this is -1. So this is minus 5i, then minus 20i. So then this is just equals to -2 minus 25i. And therefore it is represented in the form of A plus IB. So now let's look at the next question. So now the next question is, in the following problem, if you let Z2 equals to, let me say Z, not necessarily Z2, but Z, okay? You can say Z equals to X plus IY, not necessarily Z2, but let me say Z. Express the given quantity in terms of X and Y. So how can we go about this one? So we want to express this given quantity in terms of X and Y. So A real of Z square. So this is just equals to real. What is Z? z is x plus I y all squared. So this is just equals to, so this is real number, real part, then we have to multiply. So this one will be x squared then plus 2i xy, then I squared is negative y squared. So that's how we do it. So this is just equals to real part, which is x squared minus y squared, then plus 2ixy. So what is the real part of this? This is just an a, this is just like 2xy is b, so this is just like ib. So then the real part is the one which does not have imaginary unit. So yeah, this is very clear that it is very clear that real part of this one is x squared minus y squared, and that's the answer. So number B, we have this one, imaginary part of I times, this is not I but 1 plus I z, if I'm not mistaken. So yeah, 1 plus I z. So this is all about substituting where there is z x plus iy. So this is just 1 plus I x plus I y. Remember, we're expressing these quantities in the form of x and y. So this will be just equal to, so this will be imaginary part. So when you multiply here, we have x, it's 1 times x is x plus iy, multiplying this one with this one, and this one is plus ix, and that one is negative because I and I is I squared and is negative y. So is this one times this one is x, then this one is iy, this one times this one is ix, that one is minus y. So this would be equals to imaginary part of, then we have x minus y together, but plus I, then x plus y together. So but you know that this is just an a, so this guy, this one is just an a, this one is just an ib. So the imaginary part of this guy is just x minus y, and that's how simple it is. So then this come to the end of our session, or the end of our class, the end. So support me by subscribing, liking, and sharing my videos. So if you have got any question related to complex analysis, you can drop your question in the comment section or send me the question via email in the group in the description. So otherwise, thank you very much. Thank you.